According to the local Chamber of Commerce, in 1993, 5.9% of local area residents owned more than 5 cars. A local car dealer claims that the percentage has increased. He randomly selects 180 local area residents and finds that 12 of them own more than 5 cars. Test this car dealer's claim at 0.05, the level of significance. Again, we have to start the solution of the problem writing null and alternative hypothesis. We deal here with proportion because we have percentage. Percentage is always proportion if we do not have other keywords as a mean, for example. So we can claim that our null hypothesis will be p equal 0.059. What sign do we have to put in our alternative hypothesis? The same parameter, the same number, 0.059. And we have to look at the key word in the condition of the problem. In our case, it has increased. Increase means become greater, so greater is the valid sign in our case. Now, sample size in our case is 180 and x is 12. So then we have to verify our condition, and p1 minus p has to be greater or equal than 10. So we'll put, in our case, 180 as n, 0.059 as p, 1 minus p means 1 minus 0.059. Then you have to plug in everything in the calculator. So 180 times 0.059 times open parenthesis 1 minus 0.059 close parenthesis, enter. You have 9.99 approximately. Unfortunately, this is not greater than 10, so this is false, it's wrong. So we cannot use 1-prob_z test function, and we have to use binomial probability distribution. Again, we will look at sign in alternative hypothesis and x value. We have to start from x value and go in the direction of this sign. So the next number would be 13, 14, and the biggest number 180. The p-value we will find if we'll add probabilities to have 12, 13, 14, and so on up to 180 people in this sample. It's very tedious work, time-consuming work, so better to use complement. Complement is everything not included in our original sequence. What is not included? 0, 1, 2, and the biggest number not included is 11. As usual, p-value would be 1 minus probability of complement. So 1 minus binomial probability distribution, cumulative one, where you will have your n 180, p 0.059, and biggest number in the sequence which starts from 0. So you will grab your calculator, you will click second vars, you will click 1 minus, then second vars, then you have to go to binom CDF, and you will put 180, then 0.059, and 11. Click enter. The answer would be, in our case, 0.374. You have to compare this with your alpha, which is 0.05 in the condition of the problem. Clearly, your p-value is greater than alpha, so you fail to reject null hypothesis. Essentially, it means that null hypothesis value is still correct. So since 1993, you do not have any increase of the claims at all.